Titanium is an incredible metal that is used for a variety of industrial applications due to its unique properties such as high strength, low density, and excellent corrosion resistance. When it comes to producing pure titanium, the Kroll process is one of the most common methods used in the industry. Although the manufacturing process involves numerous steps, we will focus on four most important ones for now. Step 1. Mining the ore which contains titanium dioxide. Step 2. Chlorination of titanium dioxide to titanium tetrachloride. Step 3. Reduction of titanium tetrachloride to titanium sponge. Step 4. Processing of titanium sponge to usable titanium. These steps are crucial in producing high-quality titanium. Now, let's talk about Step 1. Mining the ore. Ilmenite and rutile are two primary ores used to extract titanium dioxide. Rutile contains a higher concentration of titanium dioxide, around 90 to 95%, while ilmenite has around 50 to 65%. However, the concentration of titanium dioxide in rutile and ilmenite can vary depending on the location and geological conditions. To obtain the mineral-rich sand containing these ores, mining companies use either dry or wet mining methods depending on the location. After being collected, the sand undergoes processing using a series of machines. This process removes any unwanted materials and concentrates the titanium dioxide. Then the concentrated titanium dioxide moves on to the next step. Step 2. Chlorination of titanium dioxide to titanium tetrachloride. In this process, the titanium dioxide is fed into a chlorinator, which is a large cylindrical reactor made of steel, is heated to a temperature range of 800 to 1000 degrees centigrade. Chlorine gas is then introduced into the reactor, where it reacts with the titanium dioxide to produce titanium tetrachloride. The next step involves the removal of impurities from titanium tetrachloride. Once the impurities are removed, the titanium tetrachloride is then purified through a distillation process. This process separates the titanium tetrachloride from any remaining impurities and produces a high-purity titanium tetrachloride. Now, Step 3. Reduction of titanium tetrachloride to titanium sponge. In this process, titanium is separated from chlorine. This is made possible by the introduction of magnesium. Magnesium is more reactive than titanium, so it takes chlorine from titanium to form magnesium chloride. The pure titanium tetrachloride is reacted in a stainless steel reactor containing molten magnesium and heated to about 1000 degrees centigrade. The titanium tetrachloride reacts with the molten magnesium in the reactor to form magnesium chloride and titanium. During the reaction, magnesium chloride is extracted at regular intervals. This leaves titanium solids called titanium sponge. Once the reaction is finished, the excess magnesium and magnesium chloride present in the titanium sponge are eliminated through a high-temperature vacuum separation process. At last, we have obtained pure titanium sponge that is in the form of porous granules. Now, Step 4. Processing of titanium sponge to usable titanium. The pure titanium sponge is crushed into smaller pieces using shearing machines and crushers. Then it is compressed in a compacting press. After that, they are welded together, forming a sponge electrode. The sponge electrode is then placed in a furnace made up of water-cooled copper container. An electric arc is used to melt the sponge electrode in the furnace. The titanium sponge readily reacts with the nitrogen and oxygen at high temperatures. Therefore, the sponge must be processed in a vacuum or an inert atmosphere filled with argon to prevent contamination. As the electrode melts, the metal runs down and is cooled, forming an ingot. Typically, the ingot is remelted 1 or 2 more times to produce a commercially acceptable product. After that, titanium ingots may be turned into sheets using a complex series of mechanical pressing machines, or they are shipped to another manufacturer where it can be remelted and fabricated into various titanium products. And these are some of the important steps involved in making of titanium metal.